Hi everyone, welcome back to my channel. This is Dr. Spinach. It's been a while that I posted a video on YouTube. I got busy with some stuff. However, it's better late than never. So let's continue from where we left a fortnight ago. Let's start with metabolism. Going back to the pharmacokinetic acronym ADME, wherein we have completed with absorption and distribution of the drug. Now it's time that we discuss in details about the metabolism of the drug. So what is metabolism? Another name for metabolism is biotransformation, which means transforming a drug from one form to the other form in a biological unit. That means a living cell. The first question that comes to our mind is,
why do we do that?
The primary purpose of biotransformation is to convert non-polar lipid soluble compounds into polar lipid insoluble compounds so that they can be dissolved easily in water and can be excreted out via kidney. This is basically a protective mechanism our body has developed when we accidentally ingest toxins so that they can be easily excreted out without causing any harm to our body. So the question arises that,
where does the biotransformation happen? Where do the drug transform from one form to the other form?
The primary site of biotransformation is liver. Other sites include kidney, intestine, lungs, and plasma.
Ooh, okay. Well, I'm curious to what happens after a drug is metabolized.
It can have three fates. The most common fate is that the drug is inactivated so that it cannot act on body. It can also be converted into its active metabolite and exert an effect on the living system. A drug can also be ingested in its inactive form and then converted into its active form in the liver. When we ingest a drug which is inactive and is activated after getting metabolized in the liver, this is known as a prodrug. For example, levodopa, which is used in Parkinson's disease, is a prodrug, which is converted in the liver to dopamine, that's the active form. Another example is of enalapril, that's a hypertensive drug, ACEI, which is converted into enalaprilat, that's the active form of the drug.
You told me why, where, and what of biotransformation. But how does it actually happen? What are the processes involved?
Biotransformation involves two reactions, phase 1 reactions and phase 2 reactions. Phase 1 reactions are also known as non-synthetic or functional reactions. In phase 1 reactions, drug is either broken down or a functional group is added to the drug. When the drug is broken down, it can either be rendered inactive or active. Active if you have taken a prodrug. When a functional group is added to the drug, it is transferred to the phase 2 reactions. These reactions are also known as synthetic or conjugation reactions. In these reactions, an endogenous radical is conjugated to the drug. This conjugate is negatively charged, and hence it renders the drug polar. Now, this polar molecule becomes water-soluble and can be easily excreted out.
Dr. Spinach, can you please tell me what are these phase 1 reactions that break down the drug or add a functional group to it?
Phase 1 reactions include oxidation reaction, reduction reaction, hydrolysis, cyclization, and decyclization reactions. I will not go into too much details of organic chemistry here, but let's dive deep into the most common phase 1 reaction utilized by majority of the drugs, that is oxidation reaction. What is oxidation reaction? It is addition of oxygen or a negatively charged radical, or the removal of hydrogen or the positively charged radical. We mentioned that primary site of drug metabolism is liver. But where exactly in liver? Liver consists of hepatocytes. There are two places in these cells where metabolism happens. The smooth endoplasmic reticulum, which contains microsomal enzymes, and cytoplasm and mitochondria that contains non-microsomal enzymes. Microsomal enzymes catalyze most of the metabolic reactions. These are located in smooth endoplasmic reticulum, which is located in the hepatocytes of the liver. An example of microsomal enzyme protein is Cytochrome P450.
What are these? What do they do?
Cytochrome P450 are monooxygenases. That means they add mono, meaning one, hydroxyl group to the drug or substrate. Let's now understand what the term cytochrome P450 signifies. Cytochrome is a heme protein. That means it has a tendency to bind to oxygen to carry out the reactions. P stands for pigment because it was first discovered in plants. 450 stands for the wavelength of light. This wavelength of light is produced when this heme protein is bound to carbon monoxide. Basically, CYP450 sponsors the phase 1 reactions and also carry out metabolism of most of the drugs. Moving on to the phase 2 reactions of metabolism. As I already told you, these are also known as synthetic or conjugation reactions.
Okay, so what is conjugation?
It is the covalent attachment of a small hydrophilic endogenous molecule, also known as conjugates. These include glucuronic acid, functional group acetyl, another functional group that is methyl, sulfate, glycine, glutathione, and ribonucleosides. If you remember, a functional group was added to the drug in the phase 1 reaction. It was then transferred to the phase 2 reaction where a conjugate was added. This conjugate will be either of the 7 conjugates, but the most common one is the glucuronic acid. A metabolite of the drug is formed after the conjugate is added. Metabolite formed is polar and highly ionized, which helps it to easily excrete in bile or urine. Another important concept that I would like to bring to your attention is drug interactions. Some drugs are notably either microsomal enzyme inducers or inhibitors. If a drug is enzyme inducer, this will cause the failure of another drug that you might be taking. This is because the drug will be metabolized more and then excreted out of the system. On the contrary, if a drug is enzyme inhibitor, less drug will be metabolized and excreted, and more drug will be accumulated in the body, leading to drug toxicity. Some examples of inducers and inhibitors are displayed on my screen. Remember that it is very crucial for you as a clinician to know all the drug interactions. You should be very well aware of all the drugs that are enzyme inducers or inhibitors so that you can make a rational choice of drug combination in your clinical practice. That ends our section on drug metabolism. If you haven't watched my videos on absorption and distribution of the drug, please click on the link above or below in the description. Thank you very much for listening to me. If you liked my video, please click on like, subscribe and share. Click on the notification bell down below so that you can get the updates as soon as I post the latest videos. Until then, keep safe and keep healthy. Bye-bye for now.